Good afternoon, all. Today we have with us Dr. Anna Durai. Sir is Principal Scientist Plant Breeding, ICAR-Sugarcane Breeding Institute, Coimbatore. Sir is going to deliberate on the topic of National Sugarcane Varietal Development Network. Sir, you are audible as well as visible, and your presentation is also visible. You can start, sir. Can you be a bit louder, sir? I'm not able to hear you, sir. Audio is not working, sir. Can you be a bit louder? Because your audio is not working. You are on mute. Audio isn't working, sir. Can you? Hello? You're not audible, sir. Is anybody able to listen to sir from the participants?
No, sir. No, sir.
No.
Sir, can you change the audio source of your laptop? Hello? No, you are not audible, sir. Can you change the audio source? From recording audio, you might have you need to change the audio source. No, you are not audible, sir. Can you share your entire screen? I'll tell you how to do it. From presentation, you choose entire screen. I'll tell you how to go about it. From present now, choose entire screen. From options at the bottom, present now.
Hello. Sir, I'm audible now?
Yeah, you are audible. Can you start the presentation so that we can start, sir?
Yeah. Sir,
you're audible, sir. You're audible. Just need to start the presentation.
Okay. I'm presenting now. Sharing. Am I audible, sir? Sir, I am audible to you.
You're audible, sir. But can you start the presentation?
Sir, I have shared my presentation.
No, you have shared the window which has the presentation. You have not shared the presentation. You've chosen the wrong window.
Wrong window, sir.
You have chosen the window where it is the folder of the window. You have to choose the PPT. You have to keep PPT maximized first. You can choose entire screen as well.
Yeah.
Choose entire screen, then share your presentation. That would be much better. Yes, it's perfect now. Yes, sir. Can you start, please?
Yeah. So another 20 minutes we will be discussing about the National Sugarcane Varietal Development Network. As such, if you see any organism's improvement, there will be two steps in that, according to me. It is creation of genetic variation, followed by the selection of desirable recombination. So if you see the genetic variation, that is being done by different means. With respect to selection, either we can go for phenotypic selection by seeing the phenotypes, or you can go for marker-aided selection, or you can, even in the case of transgenics, we are supposed to select the events which are having desirable traits. So this way, there's a total crop improvement of any organisms or the crop improvement program is going on. So these are all the different activities of any plant breeding program. That is creation of variation, which includes tapping the naturally existing variability or creating the new variability through this means, that is hybridization, mutation, polyploidy, somoclonal variation, and genetic engineering. After having the variation created, we have to go for selection, followed by the evaluating the petal types and multiplying the same, then distributing the petal types to the farmers as varieties. So these are all the different activities that is being followed in any crop improvement program. Coming to the sugarcane, sugarcane is a typical crop. So it is not possible for a breeder who is sitting in Kashmir to do the sugarcane breeding work. But if you take any crop other than sugarcane, it is possible for the breeder in a particular place to do hybridization or breeding work, because most of the places the crop we are going to breeder going to handle will be flowering. But with respect to sugarcane, sugarcane is a typical crop that in India it flowers only in Coimbatore. So this way, sugarcane breeding is different from other crop breeding. So in order to meet out these challenges, this challenge of sugarcane flowering at only in Coimbatore, so there is a network program called National Hybridization Programme was established at Coimbatore. This facility serves as a centralized facility for creating the variation. Here in sugarcane improvement, this total creation, that is creation of variation, is the centralized facility. Then selecting the petal types, that is second step of any crop breeding program, that is selecting the petal types, that is the decentralized program at different places. So this way, this breeding in sugarcane is different from breeding in other crops. So I was telling that sugarcane flowers only in Coimbatore. Yeah, that is true. That is sugarcane flowers and set satisfactory level of seed sets only in Coimbatore. But there is also places where the sugarcane flowers. There, UP Council of Sugarcane Research, there is a place called Zajanpur, Gorakhpur, Siragi. There are also sugarcane flowers. So whatever the varieties developed from sugarcane flowering at these places, they are nominated as UP varieties, because they are not coming to Coimbatore for developing these varieties for creation of variation. Similarly, with respect to Pusa, also there is a place called Samastipur, that is in Pigar. There also some level of flowering is going on. So those varieties which are developed from the hybridization work at Puja, they are called as PO varieties. Then newly, Vasantada Sugar Institute, ESI Pune, they have identified one place called Amboli. There also some level of seed set is there. They have established a sugarcane breeding center at Amboli in the year 2005. 2006 onwards, they are doing crossing there. Then next comes that Padehan. So Padehan, there is Ratnagiri. There in the place, there is a considerable level of flowering in sugarcane. There also, they are making crosses, and whatever the varieties developed from the crosses made at Ratnagiri, they are designating as MS clones. So Maharashtra sugarcane MS clones, they are designating. This way, there are also some level of flowering and seed set that is going on at these four places other than SPA Coimbatore. So how this Sugarcane Varietal Development Network developed, how the genesis of this one. Earlier, when 1912, the Sugarcane Breeding Institute was established, we were supplying the developed varieties to different places, and we are only from Coimbatore, the hybrids are developed were being cultivated in the other places. So here the selection process is done only at Coimbatore. There will not be any location specific importance. So here that way, breeders or scientists at the higher level, they were thinking about the location specific breeding program in 1930s. And accordingly, whatever the varieties developed by the Coimbatore SPI, they were sent to three places, that is Jajanpur, Layalpur and Karnal. So there again they were evaluated. Better ones were released as the commercial varieties for the predominantly cultivated North India sugarcane areas. So later they think that this sugarcane varieties, instead of going for 3 locations, they were sending to 46 research stations across the country to have a large number of locations to be tested in order to identify the location specific varieties. So these 46 locations from Coimbatore, the seed materials or petar canes were sent, cocaines were sent. From there, suitable ones were selected and they were given as a commercial varieties for cultivation for the farmers. Here, the problem in this particular aspect is that we were sending only 10 to 20 cocaines. So the breeder sitting at a particular place, suppose with different places of sugarcane research stations like Shahjahanpur, Sierragai, Pusa, then other places, 46 research centers, the breeders have less work. Because already the number of selections are very few. Here only 10 to 20 cocaines only we were sending earlier. So they don't have much work to work on their intelligence, on their requirement. They were unable to work on the variation because only 10 to 20 cocaines only we were sending. So alternate means we were thinking. In 1931 onwards, we were sending seedlings. Seedlings were sent. Seedling instead of cocaines, because cocaines only few cocaines were sent. Instead of having few number of cocaines, we were sending from 1931 onwards seedlings. What is in seedling also there was a problem. So while the seedlings were transported from Coimbatore to a particular location, there were a lot of mortality in the seedlings. So this led to formation of new program called the fluff supply program. So now the SBI was sending the fluff instead of sending the seedlings, cocaines, which is very less in number. This authorities in SBI and other centers, other major breeders from different locations, they thought that it is better to send the fluff from Coimbatore, so that this fluff they will be getting millions of seedlings, which will the particular breeder in a particular location will work on and select the better ones for their location. This idea was found good for the people, breeders in the particular time, and they have opted for this method, and accordingly this National Hybridization Garden was established and other works are going on. So from 1931 onwards, we were sending the fluff. So all this program was going on. In 1971, All India Coordinated Research Project on Sugarcane was established to streamline all the sugarcane research and development activities in sugarcane. So this All India Coordinated Research Project on Sugarcane have three components, that is crop improvement, crop production, and crop protection. Here we will be concentrating only on the crop improvement aspect. This crop improvement have two components, varietal trial, another one is National Hybridization Garden and the fluff supply program, National Hybridization and fluff supply program. In order to affect the varietal trials, whole India was divided into 5 agroclimatic zones. That is a very big zone is peninsular zone. Here the peninsular zone comprises of Tamil Nadu, then Kerala, Maharashtra, then Andhra Pradesh, then Gujarat, then Madhya Pradesh. This states constitutes the peninsular zone. This is the biggest zone in the network. Then followed by the northwest zone. Northwest zone comprises Rajasthan, Punjab, Haryana, then western parts of Uttar Pradesh. Then comes the north central zone. Here, eastern parts of Uttar Pradesh and Bihar regions comprises this north central zone. So that is only one state in northeastern zone, that is Assam. Then comes east-west zone, that coastal regions of Tamil Nadu, Andhra Pradesh, then Orissa are coming under this east-west zone. So this is the agroclimatic zone classification for conducting the varietal trials. So next component of All India Coordinated Research Project is fluff supply and National Hybridization Program. In this one, Coimbatore was a place where this hybridization work is going on. So we have, other than Coimbatore, we have 24 sugarcane research centers. So where the breeding work is going on. So all the 24 centers, they are getting the fluff from the Coimbatore, from the new facility called the National Hybridization Facility. When this National Hybridization Facility was established in the year 1974, the garden has only cocaines. Later, we were including the better canes selected from Anakapalli, Jalandhar, and Pusa during the year 1977. Since then, the parental clones from the earlier, the parental clones were dominated by the that cocaines that were developed from ICAR-SPA Coimbatore. Now, slowly, these cocaines, that is better canes, that the parental clones from different other centers were included in the National Hybridization Garden. Now, we have 24 participating centers in this program. Almost all the centers, they have their own parental clones in this garden, except Padodari, that is West Bengal. One sugarcane breeding center is there, that is Padodari. Other than that, all the 23 centers in this program, they have their parental clone in this crossing block, that is National Hybridization Garden. This is the parental composition in 2001 to 2020, how the parental clones are available in the National Hybridization Garden. In 2001, it was 412. It reached its peak of 666 in 2012. Again, presently this garden has, in 2020, we have 424 parental clones only. This parental clones in energy is a dynamic one. Whatever the parental clones available in the particular year, it may not be available for the coming years, because based on the utility of the parents and the flowering behavior of the parents, we will be removing the parents which were not utilized by the centers, any center, and which are not flowering. These clones will be removed, and new clones from the participating centers and the clones developed from ICAR-SPA will be included in the garden. So as such, the content of the National Hybridization Garden is a dynamic one. If you see the constituents of National Hybridization Garden, if you see the 1985, the garden is dominated by cocaines. The blue color indicates the cocaines. The cocaines dominate the garden. But in case of 2020, you see that is yellow color, that is orange color dominates the garden, that is co-allied canes. So now the co-allied canes dominate the garden. Most of the canes, the parents were from the 23 research centers or sugarcane research centers of our country. Apart from that, this National Hybridization also have genetic stocks that have been developed by the different traits, and we have ISH clones that is developed for the broadening the genetic base of the breeding pool using the unused species clones. Apart from that, we also have parental clones from foreign origin, like Sabolo from Brazil, Queensland, Karuppaiyan clones, Barbados. Like that, we have important sugarcane research centers in the different countries. Clones also we have in this garden. This is a present garden. What is the constituents? We have all the centers. As I told you earlier, we have all the centers. They have the parents in the hybridization garden. Suppose Punjab, they have 2 research centers, that is Ludhiana and Faridkot. They have 11 from Ludhiana and Faridkot 15 parents. Like that, presently we have clones from all the centers, and also clones from Barbados, Queensland, Sabolo, Canal Point, then Natal. Then also we have clone from Nailpur, that is in Pakistan presently. So this way, the constituents in the National Hybridization is dynamic and also very useful breeding material for creating the genetic variation for the total breeding program of our country. If you see the flowering pattern, this is the flowering pattern in parental clone in National Hybridization Garden. The flowering starts by 2nd week of October, and it ends by November 4th week. And November 1st week is the peak flowering, where you can see more number of clones will be in flowering stage. And after that, there will be reduction phase. After 1st week of December, you cannot find any sugarcane flower in Coimbatore. So we are studying the different climatic factors which are responsible for the flowering. Flowering is very much affected by 2 factors. One is relative humidity. Some slides were missing here. I'm sorry for that. So if you see the number of what are the climatic factors that are responsible for flowering, 2 factors are very much essential. Almost otherwise that are 3 factors. That is total rainfall and relative humidity. These are all the factors which are responsible for the sugarcane flowering. Conducive relative humidity, conducive rainfall, and number of rainy days should be there, so that there will be greater number of flowering. This slide shows you about the what are the percentage of flowering in National Hybridization Garden for the last few years. In 2017, we got a very great drought years, so we got a limited number of parental clones flowering, that is 43.33%. If you see the what are the from different, we have parental clones from different regions. if you see on that aspect, those clones which were selected from North India, subtropical region, they flowers first, followed by the subtropical clones. Region I will discuss in the some other slides. Okay, the National Hybridization Garden, we are expecting all the parents to flower, because all the parents we are supposed to use, because for a particular character only we are keeping the particular parent in this garden. So we are expecting all the parents to flower, but they may not flower in a practical situation. There are regular flowers. Regular flowers means they will be flowering through all the year, irrespective of the climatic condition, irrespective of the favorable situation in a particular year. These clones, for 35% of the clones will be flowering. Then these are all the classifications. Some clones are flowering in a 5 year, they will be flowering only 2 to 3 years. That is can flower. Timid flower means 1 or 2 years only they will be flowering. In 5 years, only 1 year flowering clones are classified as the rare flowers. Some of the clones are non-flowered. Last 3 years, if you take the 3 years, all the 3 years that particular clone may not flower. This kind of non-flowers will be removed from the garden. So that's all with respect to the flowering. So what is the different crossing method that is going on in National Hybridization Garden? We are having 3 methods, that is piparental crosses, polycrosses, and the general collections. So piparental crosses, if you take the piparental crosses, we are supposed to do emasculation. That is not possible in sugarcane. So here we are using the pollen fertility as the factor to classify the parents into different sexes. That is say female, and or male, a strong male. So that is based on the pollen fertility. That is, with the pollen fertility we are finding based on the acetocarbon stain of the pollen grains. So if it is at 0 to 20%, it is safe female, then 20 to 40%, that is female. If the pollen fertility is 40 to 60%, they are used as a female and male. If the pollen fertility is 60 to 80%, then they may be used as a male. When the pollen fertility is more than 80%, they will be considered as a strong male. In no way that can be used as a female parent, because if you are using these males and the female category as the female parent, there will be a lot of chances of getting selves. So that way, the piparental crosses are going. With respect to piparental crosses, we are doing 2 kind of piparental crosses: station crosses and proven crosses. Proven crosses are zonal crosses. Proven crosses are those which have been identified as giving desirable progenies based on the so many years of crossing and so many locations. They must have done the same number of crosses. Then better progeny giving crosses are identified. That crosses are called zonal crosses. That for different zones we are making that kind of crosses. Then station crosses means for identification of zonal crosses we are doing station crosses. Here the performance of the particular cross we don't know, so it is just a test cross. Then we have the polycross nursery. Here we have polycross nursery separately we are making. Here then the picture we are seeing first AA, BB, CC, DD. These are all the male parents, followed by F1. This is F1 not filial generation. This is female parent 1. Here we are putting 1 row fully female parent. This is male and female parents in polycross nursery we are selecting based on the synchrony of flowering and the pollen fertility. If the pollen fertility is less than 20%, that kind of flowers, that kind of parents are selected as a female parent. Higher pollen fertility parents are selected as a male parent. So here the capital AA, B, C, D, W, X, Y, Z are male parents. Now center one is F1, all F1s are female parent. So this particular female row is flanked on both the sides by the male parents. 8 male parents fertilize the particular F1. Similarly, F2 also will be fertilized by the 8 male parents. So this way we are making the polycross nursery. In case of general collection, we are collecting just open pollinated fluff. That is also giving the desirable combinations. Selves also we are doing, because in sugarcane selves also create the variation. Usually selves we are going for genetic studies. So this is the different activities that is going on in National Hybridization Garden. First we are selecting top one left, we are selecting the parents. Then morning they are collecting the portion of the arrow which is going to flower in the morning, next day, that is in the morning. Then the particular arrow is put it in the light, artificial sun, that is light is given, heat and light is given, so that this particular anther will dehisce and the pollen will be setting like that. Here topmost right down, this pollen grains will be setting. This pollen grains will be collected and they will be tested in the already caged females. So this way this total crossing program is going on with respect to piparental crosses in energy. So other than this, these are all the methods that is being followed in ICAR-SPA. Other than that, that is a solution technique, that is Hawaii and solution technique that is also being followed in other countries. That for information sake, I have given this slide. It will be available in my lecture handouts also. There also you can copy down. So after having the grasses tested, we are testing the germination test. We are conducting the germination test. So those clones, those grasses which are giving better germination are sent to the centers. So this is the seed set trend. Initially, there will be lesser seed sets. When the season advances, the seed set is increasing. This is confirmed by our studies in 2018 and 2019. So the other factors we are analyzing, what are the factors responsible for the increasing seed set. So from this you can see that flowering is getting reduced over the season, but the seed set is it is increasing. So this analysis of this work is going on to find the reason. So last this slide shows you how much number of quantity of fluff we have sent and the number of seedlings raised by them. For example, you see the first year 2001 to we have sent around 41 kg of fluff to the 22 centers. From that we got 1,64,000 seedlings. This number of seedlings were reported by the 11 centers. Among the 22 centers received the fluff. This way we are sending and we are getting the information with respect to the seedling raised. Accordingly, this selection will be going on at the particular place. If you rate the different cross combination, which is better one, there are different. This is varietal development. In this, 81% of the varieties were developed through the biparental grasses. 17% are from general collection and only 2% are from polygrasses. So next comes how we are facilitating the participating center to affect the meaningful grasses. We have the database for the yield and the sucrose traits like cane height, single cane weight, brick, sucrose, like that. And we have the data with respect to the flowering of the parents, flowering regularities, intensity, then pollen fertility. Apart from that, wherever the data is available with respect to the stress tolerance, with respect to biotic and abiotic stress, this data is available to the breeders. So this data with respect to the flower character, this cane characters. So this is with respect to among the traits, biotic stresses. Red rot is severely affecting the sugarcane. So we have the PACA database with respect to the red rot resistance of the parental clones in NHG. So we have the database of reaction of the parents to tropical and subtropical isolates of red rot pathogens. So if you see the parental clones behavior, clones that were selected from subtropical region have higher amount of resistance to red rot. Already I have told that in case of flowering also, subtropical clones flowers first with a higher intensity than the tropical clones, because reason is that those clones which were selected from subtropical region are having selected from the extremities, the high temperature, high severe cold, like that from extreme situations they have been selected. So stress tolerance capacity will be more in the subtropical clones. This stress tolerance is given by the Saccharose spontaneum genome. So these clones from subtropical region have higher level of intensity than higher level of stress tolerance, particularly for the red rot resistance. So if you see the spontaneum, it flowers throughout the year with greater intensity. So since the subtropical clones are having higher genome of spontaneum among the sugarcane hybrids, they flowers profusely and in the first half of the season, and they are also having lot of resistance to different stresses. That is the reason for subtropical clones flowering high intensity and subtropical clones having higher level of tolerance to different biotic and abiotic stresses. This database I have given in my notes. You can see anyway. We have the parents from different. We have the parents resistance to different stresses. This slide gives you information on the smut resistance parents. Actually, whenever you are utilizing the, we are selecting the higher high sucrose types, there will be a chance of getting the smut because that is a. When we are going for the high sucrose content, there is some correlation with respect to the smut tolerance, smut incidence. So this is happening nowadays in our present varieties. This was reported by Pramachandran 2012. These factors may be taken into consideration while selecting the parents for hybridization. This is with respect to rest. This is what are the breeding components, breeding methods we can adapt for the different biotic stresses. This was given by Pramachandran and Gover 2012. You can go through this, because those people who want to that, you can have it. Because I have given this one in my write-up. This is for a different question. This is resistance. All the parents are available in energy for what they can be used to stock for resistance, nematode resistance. Then we also have a different facility called the national distance hybridization facility. There we have this IK clones. There for base programming work, people can go there and they have this polar resistance parents utilized in their crossing program. This is for drought tolerance. These are all the parents available in energy for the drought tolerance. Apart from that, I have given here the Officinarum and the Parvati Robustum sinus spontaneous clones, which can be used for the drought tolerance breeding that can be utilized. Then this is salinity resistance. There are also clones available in National Hybridization Garden, and the basic species clones that are showing resistance to salinity is given in this slide. This is with respect to the other stress tolerance, that is waterlogging tolerance, cold tolerance, winter returning ability, like that. Everything is available. So other work, apart from giving the database for the different characters, we are facilitating the participating centers to have the base broadening in their crossing program, because since sugarcane itself is a base broadened product, because sugarcane breeding program started with broadening the genetic base of sugarcane, utilizing the diverse parents, diverse allied genera only. But in the breeding pool, how to diversify the parents? So for that, we were utilizing the parental diversity and the parental utilization index. If you see the total breeding program in our country, that is region specific with respect to the choice of parents, with respect to this evaluation, that is selection process. Ultimately, there are different kinds of varieties getting selected in the different regions. So if we select the parents from the different region, that itself gives the diversity. Considering this concept, this thinking, we have developed the concept of parental diversity and parental utilization index. So here the total parents were classified into 8 categories based on the origin and the genetic constitution. That is parents developed by ICAR-SPA, parents developed from the particular center. This a particular breeder from Sankeshwar, means Sankeshwar varieties developed from Sankeshwar. Then parents developed by other centers in the same zone. That is Sankeshwar in the peninsular zone. That is varieties developed from the peninsular zone. Then other 4 agroclimatic centers. Then interspecific hybrid, exotic parents. This classification is done. Then we are finding the different parents utilized by the particular center. So for example, Niagara have utilized ISH clones, cocaines, zonal classes. So there is no much I have told that 8 centers, but here they have utilized only 1, 2, 3, 5 centers only. So this way we are sensitizing them to have the parents with the more number of more diversity. Here I have given the formula for PDI, parental diversity index. That is number of parents used. For example, a particular center is making 10 classes. They are supposed to use 20 parents. But how many parents they have used? Divided by the number of classes into 2, that will give you the parental diversity index. Then we have classified the total available parents in energy into 8 classes. The PDA divided by total number of classes utilized by the particular center into total number of classes available. So using this formula, that is PDA divided by total number of classes available in energy, then among the 10 classes, how many parents from the different classes the particular center has utilized. Based on this aspect, we can go for PDA and PUA. So yeah, this slide gives the Pirmalapalli. If you take the Pirmalapalli center, PDA is 84.62, then PUA also same thing. That means they have utilized parents from all the classes. When the particular center is utilizing the parents from all the classes, you'll be seeing PDA equals PUI. That means they have utilized all the classes. For example, this Uyuru, the PDA is more, but the PUA is 71.59%. That is, PUA is less than PDA. In that case, they have utilized more number of parents, but all the classes they would not utilize it. This way, we are sensitizing them, and we are base broadening the process done by the participating centers of this network program. Then achievements. What are the achievements among of this program? After the 2000, in 2000 only that varietal notification of sugarcane was effected. After the notification, there are 57 varieties were released through Central Varietal Release Committee. Among the 57 varieties, 26 varieties are from this sugarcane National Sugarcane Varietal Development Network, that is Fluff Supply National Hybridization Program. So apart from this central varieties, there are also varieties around 150 varieties from states, sugarcane breeding centers. They have released for a particular state, they have released this number of varieties. From the 14 states, they have released this many number of varieties from this program. So this way, this program is going on. Any doubts you can ask. Thank you. Stop sharing.
If there are any questions, please ask.
Please, you can ask any questions.
Hello, sir. Hello.
Yes, sir.
Sir, I think that Padega Ursa station is not in Ratnagiri. It is in Ahmednagar district, sir, in Maharashtra.
But in report you have given Ratnagiri.
No, sir. In Ratnagiri there is no research system for sugarcane.
Okay.
Pune, it is near Pune, sir.
Yeah.
Okay.
But
There is a question in chat.
your report says that, so okay.
There is a question in chat.
Yes, sir.
Another, sir.
Yes, sir.
Sir, this year.
Okay.
Hello.
Yes, sir. I'm. You are audible, please.
Sir, this year we took plantation in the month of June. Varieties like 18024, 09004, then 11015. So all the three varieties now flowering started, sir.
Yeah.
Sir, we took in the month of June this year.
One point you have to consider with respect to this sugarcane flowering, induction period starts by August. Induction of sugarcane flowering induction start by August. In the month of August,
Okay, sir.
if a particular clone have flowering behavior, if the number of nodes during August is 3, then they will flower in October.
Sir, pardon, sir.
That is sugarcane induction, flowering induction. Sugarcane flowering induction starts in the month of August, July, August.
Okay.
During that period, if you have 3 nodes,
Okay.
if you have 3 nodes in your clone, in your variety. For example, August month, you are seeing 3 nodes. July end, you are seeing 3 nodes in your variety. If the particular variety is having the character of flowering, then it will flower.
Okay.
For flowering, 3 nodes.
Sir, but 09.
My point is,
That's okay, sir.
3 nodes are enough. They will be flowering. So if you want to arrest, yeah, we have to go for.
Sir, but 09004 and 18024 are non-flowering, sir.
Which variety, sir?
09004 and 18024, sir.
Yeah. 09004 is non-flowering type. Non-flowering clone.
But no flowering started.
This non-flowering flowering is with respect to the acclimatization of the particular clone for the flowering. If it is acclimatized, then it will flower, definitely.
Even 18024 also, sir.
Yeah. Only thing is, we are whenever there is a greater severe problem of flowering, we have to go for ethyl spray to arrest the flowering.
Thank you, sir. Thank you.
So arrest the flowering.
Okay, sir.
Particular clone is having 3 nodes at the July end or August first week, it will flower.
Okay.
For flowering during August, 3 nodes are enough.
Thank you, sir. Thank you.
There are questions in chat, sir. There is a question in chat about source of genes for nematode resistance is available.
So both male and female flowers are available. Both male and female parts are available in sugarcane flowers. Yes. Yeah.
Any other question, please ask. Because we have next session starting.
Sir, another, sir. Sir, regarding CO18024. In North Karnataka, sir, 18024.
18024. Yes, sir. Yeah.
Yes, sir. Sir, in North Karnataka, in some of the places, flowering started, but in some of the places there is no flowering.
Yes, sir. Yeah. I told you that is conducive. If the rainfall, if the total number of rainfall in a particular location is spread over the period, then there will be a chance of flowering.
Okay.
Even though both the places will be having the same amount of flowering, but same amount of rainfall. If the rainfall number of rainy days is more, then a place where the more number of rainy days are there, that particular place it will be flowering.
Okay. Thank you, sir.
Why flowering is there only at Coimbatore? Yes, because of conducive climate. Because of conducive climate, the gentle wind, the wind speed also decides. Gentle wind, relative humidity, maximum and minimum temperature during night. These are all the conducive factors that is prevailing in Coimbatore that make the sugarcane flowers at Coimbatore. Actually, this question should be different. Why is there will be a greater seed set in Coimbatore? Because as the question asked by earlier participant, sugarcane flowering is there almost many places. Almost so many places, sugarcane flowering is going on. But with respect to seed set only, Coimbatore was selected. There is a flowering. There is a flowering. We are talking about flowering in problem. Flowering problem in so many places. In Tamil Nadu also so many places sugarcane flowers. But Coimbatore was selected for its profuse satisfactory level of seed set.
Any other question? Any other question? Which chemicals are used for flowering?
Boron we can apply to induce flowering, but most of the people are asking about the avoiding the flowering. So to avoid the flowering, we can go for ethereal spray, sir. Ethereal spray, 50 ppm of ethereal spray. That is during the August, like that, in order to arrest the flowering infection. So otherwise, if you are seeing the flowering in 1 or 2 canes, then you can go for ethereal spray so that this amount of flowering will be reduced.
Any other question?
Sugarcane flowering will be very dangerous for the farmers. Breeders, it is a happy occasion. For farmers, it is a very undesirable one. For farmers, it is undesirable one. So once flowering starts, means there will not be further growth. There will not be any further sucrose accumulation. So both the person, that is sugarcane breeders have 2 consumers. One is farmers. He want more yield. Then one more consumer is millers. So because of flowering, both yield and also sucrose accumulation will be reduced. So when flowering starts, there is no further yield components growth. There is no further sucrose accumulation. In both aspects, it will be reducing. So sugarcane flowering in farmers' field is disadvantageous one. Sugarcane flowering is needed only for the breeders, that too in breeding places, especially in Coimbatore. In other places, we don't expect them to flower. So we are selecting against flowering, actually. We are selecting against the flowering.
Any other query? Please ask. How many seeds will set in one inflorescence, sir?
Okay, that is very good question. Actually, we have florets are very small. So around 20,000 florets will be there. So 20,000 florets will be there in a single arrow. So if everything goes nice, we are expecting around 500 to 1,000. Because initial and if you take the sugarcane arrow as such one, initial 20% will go as a sterile only. Initial flowers are sterile. Then those florets which flowers in the last of the this last portion, this base portion of the arrow, that will also be sterile. So middle portion only will be fertile, and they will be having the chance to get fertilized. So around 1,000 to 2,000 seeds based on its own pollen fertility, we can expect the seed set.
I think yes, sir. I think we have gone over our time, allotted time. Sir is to next session is starting soon, sir. Yeah. On behalf of the organizing committee and on behalf of NADCL, would like to thank you, sir. Thanks a lot for joining and sharing such wonderful insights. Thank you. Thanks a lot, sir. Thanks. Participants, please wait. Our resource person is joining us again. Hello, sir.
Window. Sir, I am ready.
Yeah. Can you come closer to the laptop? You are a bit far away from the laptop, and can you start the presentation, sir? Lighting is a bit. It's coming from your behind. Lighting should be up front, anyways, because that's creating a shadow on your face, sir. Anyways, sir, can you start the PPT?
From there.
Yes, the right option.
Okay, no problem.
And like a plus X. It is sudden putting echo eye.
Yes, sir. Sir. Hello. Hello. Can you hear me, sir? Yeah. Presentation is fine. Can you start the presentation and unmute yourself so that we'll be able to see, hear you as well.
Sir, good afternoon.
Yeah. Good afternoon, sir. Can you start the slideshow?
Sir, good afternoon.
Good afternoon.
Am I audible and visible? Yes, you are. Okay.
Yes, sir.
I think if there is no problem, I can start my presentations. I have been allotted a very limited time already, 3:30.
No problem. You can start, sir. You can start.
I will try to complete at the earliest. Before start my lecture, I am grateful to the organizers, very respected organizers and coordinators, for giving me the opportunity to present this a small topic on the wide hybridization in sugarcane. I will straight away go to the topic. I will be covering on 4 aspects. One is the species of sugarcane and its origin. Then coming to the interspecific and intergeneric hybridization, some of the problem faced in the interspecific and interspecific generic hybridizations. To enter into the subject, in many of the crop improvement program, crosses are made, hybridization are made between varieties belonging to the same species. It is called general hybridization or close hybridization. But in many crops, it is often desirable to have crosses between individual belonging to 2 different species, or it is sometimes very much essential to have crosses between varieties belonging to different species of same species or same genera or different genera. So if it is a same genera, it is called interspecific hybridization. If it is a very different genera, it is called intergeneric hybridization. And both together called distance hybridization or wide hybridizations, because they are taxonomically more distant than the normal intervarietal hybridization program. This is the definition of wide or distance hybridization. With this small introduction, now before understanding the wide hybridization, it is better to know the species of sugarcane and its origin, so that we can, when we say that this species is crossed with this particular species, unless if you do not know the species, it is very difficult to understand. So I have given the species in the introductory part. So let me move to the first one. The Saccharum robustum is the first, probably this is the first sugarcane, the primitive form of sugarcane, but it is a wild species, not available anywhere in the cultivated in the homestead. What it was found only in the Papua New Guinea, that is particularly in the Melanesia. It's look like a sugarcane, but the speciality of this species is there is no juice in this. No juice. Even if you extract a little juice, it won't be sweety. It look like a normal plant, not a sugarcane, but morphologically it looks like a sugarcane. The chromosome number is around 60 to 80, 60 and 80, both the types are there. I told you it was found only in jungle. People those days were did not care, only those during the exploration during 18th in Papua New Guinea. It was collected. If you see this left side figure, this is the explorer and the tribal are just climbing on the particular species. Again, one more person can climb. So that means it is around 20-25 feet height material. So that's why it is robust. So it is called robustum. And people used it for actually it was in jungle only. When you split open the cane, the robustum cane, you will find the red fleshness. Sometimes white fleshness also common, but this particular species is alone is having red fleshness. That's why it is distinguished from the other species. So it is not eaten by the wild boar. It is not eaten by the rat. So it is people using it is for a fence purpose. Then next species is Saccharum officinarum. We call as a sugarcane. When common men call sugarcane, we refer to the Saccharum officinarum. It is also called noble cane because it is having juice, and the juice is having sucrose. The chromosome number is 80. Probably this is evolved from the Saccharum spontaneum species, which the origin is also from the New Guinea. Lot of variability. If you see this picture, you can find out lot of variability in the species, right from the normal sugarcane. This is entire cane is a purple color. The right side is green color leaf with purple color stem. The color ranges from light green to dark purple. So the another form of species, cultivated species, is named as Edule. In Java, Indonesia, it is called Turuka. That is a local name. It is having a chromosome number 80, similar to Saccharum officinarum. But Saccharum officinarum will put forth flower, but this species, flowering symptoms will be there. The flower formation will be there, but the flowers, if you see here, it is not at all opened. There is a malformation in the flowering. It won't be open. And the people those days, the tribal collect this flower and market it. When you split open the flower, it look like a baby corn, and it is more flesh, very delicious, highly delicious. So it is edible. So it is edible. So it is called Saccharum edule. It is mostly cultivated for the inflation, not for the sucrose purpose, sugar extraction. So these three species, what I spoke just now, so they all have originated in this region called the Melanesia. That here the one particular place is called the Papua New Guinea, just above the Australia. So this is the center of origin of these three species. Then coming to the ancient India. So in imagine that is 100 years India, that is 2000 years before. Yes. Okay. If in the ancient India, just in the northern, particularly in the northern belt from the combined Uttar Pradesh, Bihar, Bengal, and the northeast region, there was a type of sugarcane was cultivated, and in the adjoining region also, particularly in the China and the Burma, a little different type of sugarcane were cultivated. This type of sugarcane are indigenous to these particular regions, though they are called North Indian cane, which belongs to the species Saccharum barbari, and Chinese cane Saccharum sinensis. So these two are indigenous to India and the adjoining regions. If you see this Saccharum barbari, it's look like more or less a leafy nature. More, it is a very thin cane with the cylindrical, only the difference is the cylindrical internode, high fiber, tolerant to the winter, the low temperature prevailing in the North India. But this species is not in cultivation right now. Then another one is Sagarum sinensis, very close to the Sagarum barbari, but with having a higher chromosome number. The internode is a little bit bobine, and the leaf is a little yellowish in nature. It was cultivated in the higher altitude area of the China and the Burma region, but it is not in cultivation right now. There were, before the introduction of the modern varieties, particularly in 1918, there were around 95 to 110 clones had existed in India, and this list is shown here. This is about the cultivated species, which I have, that 5 species listed. Another one is the Sagarum spontaneum. This is a wild species. Many of you know that it can grow under extreme drought. It can grow under the extreme waterlogging condition. So it is very close to the sugarcane, and it is viewed as one of the potential source in the intraspecific or intergeneric crosses. So a large number of different types. Each one is different in terms of the number of chromosomes. They are called cytotypes, from ranging from 40 to 2N to 40 to 128. 31 cytotypes have been distinguished, and they are very good sources of high tillering, drought tolerance, and waterlogging tolerance is there in this species. Then these all 6, I listed about 6 species of Sagarum. And this, in addition to the Sagarum species, which are the species which are close to the, or the genus which are close to the Sagarum is Erianthes. In that Erianthes, we have 4 or 5 species. The most important one is the Erianthes arundinaceus, which is given in the left side with the chromosome number 30, 40, and 60. It is a cane forming type. It looks like a sugar cane, but no juice, no sucrose. The other one is Erianthes procirus, given on the right side. And the third species is Erianthes ravene with very good vegetative vigor. The Bengalensis you can find in the North India. It is called munja grass locally, or sarkanda. This is also belongs to the Erianthes bengalensis. Then in addition to the Erianthes, there are 2 more genera related to sugarcane. They are called, the one is Sclerostachya, and because having more sclerosis, and the another one is the Naranga porpyrocoma. So this all, and one more species, one more genera is there, that is called Miscanthus. It is, you can find it in the high altitude. It is a very cold tolerant crop. It is temperate region crops. You can find it in the Nepal, adjoining Chinese regions. So 2 species are very important. One is the Miscanthus sinensis and the Miscanthus floridulus. These 2, it is a source of high biomass as well as the source for the cold tolerance in this species. So what I have listed is the genera and the species which are closely related to the modern sugarcane. So to summarize this, just above the Australia in the Melanesian island, that is particularly in the Papua New Guinea, there were 3 species originated. One is a Robusta wild one, and 2 cultivated Officinarum and Edule. And in the Indian subcontinent, and particularly in the Northern Indian region, there are 2 cultivated species, Sagarum barbari and Sagarum sinensis. And Sagarum spontaneum is native to Asia, particularly the northeast regions. So these 3 existed here and 3 existed here. And the interspecific, probably by natural as well as the man-made interspecific hybridization, have given rise to the modern sugarcane cultivars. How we will see it. Now the interspecific hybridization, that the core topic is we will be going. And before I start the interspecific hybridization, let me to just introduce. Before the interspecific hybridization, normally the sugarcane breeders across the world, what they started is, they were the first form is they introduced the sugarcane from the place of origin. Particularly this right side picture, one place is called in the Polynesian island Tahiti, where the one cane was found Watahati. From there it was introduced to the Hawaii, and then from here it was introduced into the West Indies, Indonesia, again West Indies, when it was introduced in the different places, the people named in different names in like Lahaina, Bourbon cane. And when it was introduced in the India, it was called Vellai. And from the Dahiti Island, it was introduced into the Mauritius Reunion. From there, it came to India. This kind of introduction took place. And in addition to that, in India, because it probably very few records speaks like this, in India, we had in the ancient India, we had a natural hybrid, interspecific hybrid between Sagarum officinarum and our Indian cane, North Indian cane Barbary, which existed, but the people did not name it. Only in the French people, when they took it to the country, they named as a Creole cane or Kanna Creola. It was probably the local name Puri cane. So it was the first natural hybrid, and it was cultivated in India. From there, it was taken by the by Arab, and then it was introduced into many countries. It was the first sugarcane cultivated probably more than 250 years in the world. Then if you see this origin and the spread of sugarcane, already I told in India two species have originated and natural hybrid also came. When Alexander came to India, he saw that jaggery was manufactured in India, and probably his army men took this cane to Egypt, Mediterranean region. From then it went to the other countries, African countries. From here it went to Europe. From then Europe it went to Brazil, then other countries. So it took nearly from 600 to 1500 region to spread the modern cultivar from this place to the entire country. Then there was a cane, another in addition to the Watahati cane, there was a cane in the Java, Indonesia. It was a colored cane, so people call them as a jeriban with the different colors are there. In the Vanuatu Island, particularly in the Polynesian Island, there was another cane, different cane, Tanna Kanna cane, that was also introduced. And then another adjacent to Australia, there was another form called Padilla cane. So these four kind of officinarum canes were initially popular up to 1900. Then in the year 1887-88, there were two important discoveries in this era of sugarcane breeding. In the Java, the sugarcane flowering and the sugarcane flower was discovered, and the sugarcane seed set was discovered, and the seed germination also was discovered both in Java as well as in the Barbados, independently by these three scientists. So this has made, because until then no one knows that the sugarcane forms seeds and the sets and the seeds germinate. So after the discovery of seed setting and the seed germinations, there were a lot of interest. Then the people started growing seeds, and they were started selecting better varieties from the naturally existing officinarum type. Then what happened? Then the people started crossing between the different clones of Sagarum officinarums, and the progenies, from the progenies, different canes were selected, and they were become popular up to 1920. But most of the high-yielding varieties here in the given in green color selected were either susceptible to Serra disease or the viral diseases or root rot diseases. So there was a interest, there was a necessity between in the year probably 1890s to develop a sugarcane varieties resistant to the prevailing root diseases and the particularly Serra diseases. It's a viral diseases, very common in the Indonesia. So it was by Dr. Jesuit. He was the first person to make interspecific hybridization in sugarcane. That is a core part of my topic. Not Jesuit, that is Walker. In fact, Walker, he himself made in 1893, he made crosses between Sagarum officinarum and a naturally occurring wild species in the Indonesia. Later on, it was found to be a natural hybrid, but it was having the wild nature, and the hybrid was made. Then the hybrid was again backcrossed with Sagarum officinarum 3 times, and from this, a clone was identified called POJ2878 by Dr. Jesuit, and this was called the very, very wonder cane of the world. First wonder cane of the world. It has probably revolutionized the sugar industries for nearly 40 to 50 years. And again, from the Indonesia, the Dutch scientist Cobus, but the POJ2878 was susceptible to Seri diseases. So in order to develop a varieties resistant to the Seri diseases, attempts were made. In that attempt, that one scientist called Dr. Cobus, he visited India, knowing that in India, particularly in the Uttar Pradesh, Bihar area, an indigenous cane was cultivated. He came to Shahjahanpur. He took our Indian sugarcane varieties called the Chunni, and in the year 1893, he made crosses between Sagarum officinarum and our Sagarum barbari canes, and the hybrid was found to be resistant to Sera diseases. From that, 4 or 5 very good varieties were developed, and the POJ213 is very, very important varieties. And this was the initial development in Java. But when we come to the India, we started in India the interspecific hybridization, or the sugarcane breeding program in India started with the interspecific hybridization program. It started a little later than Java. In 1912, the Sugarcane Breeding Institute was established. Dr. C.A. Barber, a Dutch scientist who was working in the botanical garden of the Botanical Research Institute of Calcutta, was asked to lead the sugarcane breeding program in India. He was the first founder director of this Sugarcane Breeding Institute. And he made crosses in Sagarum officinarum and Sagarum spontaneums, that is officinarum is the Vellai, the Ottahatti forms available in India. And from this high yielding varieties was obtained. That number was given CO0201 up to 101 to 212. Very good material was got, but only one material, CO205, was released as a very good commercial varieties in 1918 itself in the Punjab state. It has replaced many of the local varieties, local cultivars grown in that area. But even then, there were some specific some issues with the first interspecific hybrid. Then it was thought that to introduce some of the sugarcane material developed in Java to India. Then under his junior is Dr. T.S. Venkatraman. In fact, he introduced the POJ213. I already told you it was developed using our Sagarum barbari clone, Chunni. It was developed in Java, and this material was introduced. It has revolutionized the Indian the breeding program, sugarcane breeding program. The POJ213 was crossed with the initial material developed by Dr. C.A. Barber, particularly CO206, and then he obtained a hybrid which is having the blood of Sagarum officinarum, Sagarum spontaneum, and the Sagarum barbari. So it is called a tri-specific hybrid. Such as tri-specific hybrids are released as a commercial varieties like 281, 213, 312, 313 were very popular in particularly in the North India those times. And then the interest in the interspecific hybridization last, because there were a lot of nobilized canes, and the nobilized cane, then the next era of breeding was to make crosses between the nobilized canes, and it also led to many of the high yielding varieties. One of the success in the interspecific hybridization is that between the Sagarum officinarum and the Sagarum spontaneum is the unreduced transmission of unreduced gamete. Normally, when gametes are formed, the chromosome reduction takes place during meiosis. But when there is a cross between officinarum and the spontaneum, probably the spontaneum gene, the pollen induces the officinarum to form an unreduced gamete. The number should be 40 here, but it is 80. That means unreduced gamete form, and the hybrid number is increasing here. So when the F1 hybrid is again backcrossed with officinarum, this officinarum forms an unreduced gamete. The chromosome number in the resultant hybrid is again increasing, and it goes up to the second backcross. Up to second backcross, in many places, many cases, the 2n plus n transmission is recorded, and it was because of the presence of higher amount of Sagarum officinarum chromosome. Despite the Sagarum spontaneum is a wild species, and the immediate hybrid is having commercial worthiness because of the excess number of Sagarum officinarum genome, and that is due to the unreduced gamete. So here, if you see the modern cultivar, commercial sugarcane varieties available today, they may be having around 80% of the chromosome from officinarum and 10% from the spontaneum, and 10% of the clones is the recombination from between the Sagarum officinarum and the spontaneum. So this is very true picture of the interspecific hybridization in sugarcane. I already mentioned that the interest in interspecific hybridization last around probably 1940. Then at the Sugarcane Breeding Institute, that base broadening program was started under the leadership of Dr. Kandasamy. So there were many crosses were made involving Sagarum officinarum, Barbary, Sinensis, Robustum, Spontaneum. The crossing program consisted of 2 stages. In the first stage, our indigenous material, Barbary, Sinensis, and wild species, Robustum, Spontaneum, etc., all these were crossed with officinarum and the commercial hybrid. The resultant in the second stage, the resultant hybrid were back-crossed with the again officinarum and commercial hybrid to produce the second stage numbulation hybrid. The hybrids were evaluated at Coimbatore as well as under Karnal under subtropical condition by including by our present director, and from this many hybrid, interspecific hybrid, it is named as ISH 1 to 300 were selected, and these 300 are some of them are available in the National Hybridization Garden, and it is utilized by the sugarcane breeders in the world. Then again, there is at SBI that base broadening program, that the improvement of species like officinarum, spontaneum, robustum were taken place. They are called improved Sagarum officinarum, improved Sagarum robustum, improved Sagarum Barbary. So the crosses were made between improved Sagarum officinarum and the spontaneum, and then it was back crossed. Now the interest is not to develop commercial varieties. Now interest in the interspecific hybridization is develop energy cane. Many energy cane with high fibers, close to 26 to 27%, have been developed from the crosses between the commercial sugarcane and the Sagarum spontaneum, and many of them are tested under sugar mill. Then the Sagarum officinarum and robustum, but unlike the officinarum and the spontaneum, they follow the n plus n transmissions and plus aneuploid transmissions. This is about the intergeneric, interspecific hybridization in brief. Now I will move to the third part, is the intergeneric hybridizations. So sugarcane is very, very wonderful species, the Sagarum, and it is a very complex, though people call them as complex, but the complexity does not make any hindrance in the hybridization. The genus Sagarum, it was said that it can hybridize with 8 genera, including the Erianthes, Miscanthus, Narangas, Sclerostakia. These 4 are easily hybridized. They are called Sagarum complex by Mukherjee, and it can also be easily crossed with Miscanthrium, Rhiphidium, Sorghum, Bambusa. So now let us examine some of the intergeneric hybrids developed at Sugarcane Breeding Institute. This is the first intergeneric hybrid was developed by Dr. Barber by involving Sagarum officinarum in the Naranga porpyrocoma. So it is this species is having drought resistance, hardiness, even salinity resistance, and the hybrid were confirmed. The another interspecific hybrid, intergeneric hybrid, was made by Parthasarathi and Venkatraman using the Sclerostakia as a male parent. And then the third intergeneric hybrid is the officinarum in the Imperata cylindrica, produced by the classical cytogenetist Dr. Janaki Ammal. And this photograph, very old 1935 photograph, very important materials, first report on the intergeneric hybrid between the Imberetta and the Saccharum officinarum. Then the sugarcane and the bamboo crosses, 1936 itself, the crosses were made by Dr. Venkatraman. And in spite of, there are a lot of taxonomic differences between the Saccharum and the bambusa. So it crosses both the species easily hybridizes, and even the hybrids are available at Kannur as well as the Coimbatore. Then the miscanthus, sugarcane in the miscanthus, it is nicknamed as a miscane, because I already told you that miscanthus is viewed as an important source for the biomass, high biomass and cold tolerant. In Japan, many hybrids, viable hybrids have been developed, and they are called miscanes. In fact, we have a natural hybrid between the Saccharum and the miscanthus, and the first artificial hybrid was produced way back in 1948, and many new hybrids are available. Then the sugarcane and the maize hybrid. Maize is also a cereal crop, and at our Sugarcane Breeding Institute, the first hybrid was made in 1941 itself by using the Saccharum officinarum clone Vellai and the Sia maize, one variety, that time it was called Golden Beauty. But the seedlings were very, very miniatures and dwarfed, did not establish well. But despite a lot of difficulties, that was maintained for many years. In the year 1983, Dr. Srinivasan and Jalaja cultured the material in tissue culture, and they established the materials of this hybrid. And again, this material was again subsequently used for many of these cytogenetic studies. It showed sterility, because we could not use it in the further breeding program because of the high level of sterility, and the presence of maize chromosomes and the B chromosomes in the Saccharum Sia hybrid was also confirmed by Dr. Sobha Kumari using the genomic in situ hybridization technique. Then coming to the next one is the sugarcane and the sorghum hybrid, way back in 1930 itself by Dr. Thomas and Venkatraman of SBI. Produced the first successful hybrid using POJ 2725 and the Perimengal solemn, that is a sorghum genotype locally grown here at Coimbatore. But the hybrid was very, very dwarf. Our earlier director, Dr. Nair, he obtained a hybrid between Saccharum, the commercial variety 86032, and sorghum as a male, and the hybrid had a 2N chromosome of 66. Again, Doctor, in the year 1999, Dr. Nair obtained an intraspecific hybrid using sorghum as a female parent. Earlier cases, Saccharum as a female. Here, in this case, sorghum as a female. But the frequency of viable progeny hybrid was very, very low, and he got only 2 hybrid with the 2N chromosome of 66. Then there was knowing that there was some problem in sorghum and sugarcane crosses in Japan. Fordnet et al. They have used a mutant lion called which is having the IAP inhibition of alien pollen mutant, and it was used as a female parent, and the Saccharum also was used as a male. They got a very high success rate. Sorghum sugarcane hybrid was obtained. Then one of our scientists, Dr. Mohan Raj, also he developed he registered a genetic stocks with the NPPGR, which accumulate high level of sugar at the early stage itself. So this is with respect to, this is the hybrid, and the presence of sorghum chromosome in the hybrid was also confirmed by using the genomic in situ hybridization technique. Then the generic hybrids between the sugarcane and the Erianthus, because a lot of interest on the Erianthus is nowadays have been forward. And in the year 1928, in fact, way back, the first crosses were made using the officinarum clone and the Erianthus ara. At Sugarcane Breeding Institute, the intergeneric crosses between sugarcane and Erianthus started way back in 1941, and the first hybrid was produced by Dr. Janaki Ammal between the Saccharum spontaneum and Erianthus ravana. Again, Dr. Tuljaram Rao sir obtained a hybrid Saccharum officinarum and Erianthus ciliaris. Nair also obtained two hybrids between Erianthus procerus in the Saccharum officinarum. In Japan also, Fukuhara and Babil reported successful intergeneric crosses between these modern sugarcane cultivar and Erianthus arundinaceus. But in many of the cases, the sugarcane and the Erianthus crosses, the hybrid is they are less vigorous, less fertile, and they do not flower. Since they lack flowering, further advancement through breeding is restricted. To avoid this problem, another idea was to use a bridging species. In that, the Saccharum spontaneum came as a boon. Then, because Saccharum spontaneum, though it is a wild species, it can easily cross with the Saccharum. That means sugarcane, it can easily cross with the Erianthus. So, on this idea, Dr. Nagarajan of Sugarcane Breeding Institute, he made crosses between Erianthus arundinaceus and the Saccharum spontaneum, obtained a hybrid, and the hybrid showed 0 to 15% pollen fertility, but very low fertility. He could not advance further. But Dr. Premachandran, he made a reverse crosses. Saccharum spontaneum is a female, and Erianthus arundinaceus as a male, and he got an F1 hybrid. And the F1 again is backcrossed with the commercial material, sugarcane material. And in the third backcross stage, he got a very good high yielding, high sugared material named as a CO15015 with a chromosome number of 106. And this CO15015, if you see the right side picture, it is having two Erianthus arundinaceus chromosomes that it is established very well using the GIST technique. And probably this is the first report in the world which is having the alien cytoplasm as well as the chromosome from the Erianthus species. And this is the photograph showing the Erianthus arundinaceus and the spontaneum hybrid, but it is not flowering. Then another one is using the bridging species, Saccharum spontaneum, and Erianthus bengalensis was used as here the male. And the hybrid was repeatedly backcrossed with the commercial sugarcane, and the material cocaine called CO16018 was developed with high yield with sucrose, high sucrose. And the fifth generation backcross, it is now in the All India coordinated varietal trial in the peninsular zone. So these are only some of the development with respect to the interspecific intergeneric hybridization in sugarcane. Because of the limitedness in my time, I started my presentations. I am ready to answer. Now I stop my presentation at this stage. If there is any questions, I am ready to answer. Thank you very much.
Thank you, sir. Thank you, sir. Thanks a lot, sir. There are few questions, I guess, in the chat, and the session is open for Q&A. Please ask if any query you may have, sir will answer. Sir, you can check the chat for questions.
Okay. Root knot disease was found in some roots in sugarcane. Please describe to go to. I think the question is regarding root knot diseases that was reported in the Java, particularly in the Saccharum officinarum species. Now it is not root knot. It is not. It is a viral diseases, not mistaken with the nematode.
Any other question, please ask. Any other question, please?
I think I am seeing a lot of participants, more than 83, 80. This is a first wonderful virtual training program with a lot of participants. Thank you to the organizers.
Yes, sir. Yes, sir. Any questions? If there are no questions, we can consider this session to be over. Any interaction or any feedback you would want to give? There is a question: wild species used for sugar percentage increase. In chat, sir.
Wild species used for sugar percentage increase. One is the Saccharum spontaneum. That was the wild species used right from the 1893 onwards. So when there is around 10% of Saccharum spontaneum genome in the hybrid, and there is a considerable increase in the sugar content. There was an experiment in the Hawaii to increase the number of chromosomes of Saccharum spontaneum in the hybrid, but the resultant hybrid had more than 150 chromosomes, but they were less sugar, very weak. So it is concluded that the Saccharum spontaneum also at limited 10 to 15% percentage of contributions add to the sugar content of the Saccharum officinarum, combining the resistance. Are energy cane cultivating commercial in India? So the next question is the energy canes are cultivated in India. There was a proposal, actually the energy cane, type 1 energy cane, type 2 energy cane was tested in sugar mills in Andhra, Karnataka, and also the Tamil Nadu Papers Limited, Karur. It is not commercially cultivated, but experimentally it is being cultivated on large scale. The energy canes, what the recommendation is, it is not for on the normal land, only the degraded land, abundant for land. It is the idea is to promote the energy cane cultivation on for the degraded waste forest land, so that it will not compete with the regular crop. It is not commercially cultivated as of now in India.
Any other question? Sir, I think we have gone way over our time. I'm sorry, there was an initial delay from the first speaker. Why? Because he was thinking like the session was about to start at 3 when we have mailed him, I guess, 3 days ago, and we have also informed that session is going to start around 2:30. Anyway, sir, thank you for your valuable time. And on behalf of the participants, on behalf of the organizing committee, and on behalf of NDCL, thank you very much, sir. Thanks a lot for these insights. It was a wonderful session. Thank you, sir.
Thank you very much for the organizers, coordinators, and all the participants for your passion listening. Thank you very much.
Thank you.